In a world driven by trust, breaking it has dire consequences. We rely on courts, contracts, and governments. Yet when trust fails, we face fraud, corruption, and even wars. So, when discussing Web3, blockchain, and decentralized storage, it's more than technology. It's about how we choose to allocate the cost of trust, toward people or math. Public blockchains like Bitcoin and Ethereum challenge the norm. They shift the focus from trusting individuals to trusting math and code. Trust is replaced by thousands of anonymous computers verifying transactions. When you write data to the blockchain, every node gets a copy. Miners or validators perform complex calculations to determine what is true. This process may seem inefficient, but it's purposeful. Compared to the costs of failed human trust, the energy and resources expended appear justifiable. You might wonder, why not store everything on chain? While blockchain is inherently trustworthy, directly housing large files is impractical. Every node would need to retain a complete copy forever. Instead, projects typically store a tiny hash on chain, acting as proof that the file hasn't been altered. The actual files reside off-chain, with the blockchain merely verifying their integrity. So, where do these files go? Enter IPFS, Pinata, Filecoin, and Arweave. IPFS, or Interplanetary File System, is a peer-to-peer protocol. It breaks files into chunks, giving each a unique content hash. Pinata serves as a paid pinning service for IPFS, ensuring reliable file hosting. Filecoin incentivizes storage providers with fill tokens for securing your data. Arweave offers permanent on-chain storage. You pay once, and the network maintains it indefinitely. But why rely on countless strangers? Couldn't a few reputable organizations do just as well? This leads to the concept of permissioned blockchains. These allow only pre-approved organizations to verify data. This method is faster and cheaper, but it requires trust in the entities involved. It functions well for sectors like supply chains, banking, and healthcare. However, the risk of collusion among 5 big organizations often outweighs the risk of numerous individuals taking advantage. This model resembles governance systems. A centralized server mirrors a monarchy, efficient but requires total faith in one ruler. A permissioned blockchain reflects a democracy, where shared governance can lead to hidden agendas. A public blockchain embodies radical freedom, integrating checks and balances, albeit at a higher operational cost. Is decentralized storage a waste of resources? If measured solely by energy used, perhaps. But if we consider what humanity has historically invested to maintain trust, military forces for land security, courts to resolve ownership disputes, laws to prevent fraud, machines verifying each other seem cost-effective. They don't demand bribes, alter history, or forget. How does this apply to everyday applications? Take a budgeting app like Jajan Tracker. Completely blockchain storage is excessive for daily spending logs. Instead, a good database with backups and user permissions suffices. You might keep small hashes on chain for essential receipts or statements to prevent tampering. In exploring these ideas, we reach the fundamental question: decentralization comes at a cost. Trust is never free. The choice boils down to, how much do I pay people to ensure honesty, and how much do I pay machines to fulfill the same role? Blockchain, IPFS, Filecoin, and Arweave are modern experiments addressing this timeless dilemma. Your lunch receipts may not need such safeguards, but society's public records likely do. Take a moment to reflect on your own trust choices. Which path will you choose? People or machines? Your decision is part of a larger movement into the new realm of decentralized technology. Discover more and explore how these concepts shape our world. Subscribe for deeper insights into the evolving landscape of trust and technology.